recap of study unit 8 and 9. So let me just make sure that the recording, yes, the recording is beginning. Okay, so we're going to do a recap on study unit 8 and 9. Just again, this assignment 4 is submission date is 9th of August. There has been an extension. And just that I don't know if the official communication went out, but it is on the assessment portal. When you submit, it tells that the assessment is available till the 9th of August. Okay, so let's look at a recap of study unit 8 and 9. And I think what is important, and from the discussions on WhatsApp as well, on our group, that it's nearly two things that I want to just do a recap of. And the one is, when is something one tail and two tail, and then what do we do with it, and how do we use some of the formulas, and how do we look at it from critical values and things that we need to calculate. So for me, the one thing that is important is, and let me just get, so there is only one instance when it is a two-tail. So there's only one instance when it's a two-tail, and that is when your alternative hypothesis is not equal to. Okay. Only time when it's two-tail is when your alternative hypothesis is not equal to. So the one tail is then for all the other opportunities or other possibilities for the null hypothesis. It can also be, and in this instance, we're talking about, so your null hypothesis or your alternative can be the smaller, but it can also be smaller and equal. The same on the other side. It doesn't need to just be the smaller. So it can also include the smaller and equal, or bigger than and equal. So for one tail, there is basically four possibilities. And then for your, that's basically looking at just the bigger one and just the smaller. So you have four possibilities for one tail, only one possibility for two tail, and that is the not equal to. So then the question is always, okay, so if I need to look at my alpha for a two tail, you will divide it by 2. But just remember, two tail, you divide by 2. One tail, and it's not there, but you can say, well, one tail I divide by 1. And that is in any case your normal alpha. So if you work with a two tail, divide the alpha by 2. If you work with a one tail, you divide the alpha by 1, which is still alpha. And the place where we will use this is when they tell us in the hypothesis testing that we test at a 95%. So if I say we're testing at a 95%, we need to work out the alpha, and the alpha is basically 1 minus the 0.95, which is 95%. So the alpha would be 0.05. So then if we have a two tail, we divide it by 2. If we have a one tail, we keep it as 0.05. Okay, so that is nearly when we work with hypothesis testing, how we work with one tail and two tail, and then what we need to do with the alpha. The other thing that I included in this is also, and this is in your study guide as well, but it's easier if it is also with the two tail and one tail in the presentation. So when we look at confidence intervals, I did that now. Okay, let me just quickly see what is happening here, why I didn't want to. Okay, so when we look at the confidence intervals, there is only 3 confidence intervals that we will work with in this sub or in this in stats. So we will work with a 99%, 95, and 90. Most of the time we work with 95, but it can be that they include the other ones. So when we look at confidence interval, remember there's always a top and a bottom. So there's a lower confidence level and there's an upper confidence level. It doesn't mean that they will always ask you to work out both, but if they ask you to work out both, there's a lower and there's an upper. So if there's a lower and an upper, we're always working with two tails. So when we have the two tails for confidence interval, you will always work with these numbers. So that's why in the previous session, if I see confidence interval with 95%, I automatically go to 1,96. I think on the chat, it was asked about when we did hypothesis testing, and it was set hypothesis testing at 10%, and it was using a one tail. How did we know it is 1,28? Well, it's not because I'm looking at tables or anything like a Z table. I'm using this. So 1 minus the 90% gives me that alpha that was equal to 10%, or the alpha that they can give you sometimes as a decimal as 0.1. And because I have this, and again, we don't need to learn it, we have it at hand, I can go and say, well, we looked at the hypothesis, it was a one tail with a 10% confidence or alpha, we can automatically say it's 1,28. Okay, so nearly with these two tables, one can do a lot of this table, and with the two diagrams or 3 diagrams, we can actually nearly complete all the questions for study unit 8 and 9. So let's look at a few examples. There was a few questions that were shared on the chat that I will look at, and then I also looked at one of the other previous exam papers just to include 1 or 2 other questions. So let's look at some of the examples. So because it's a previous exam paper, sometimes the print is not the best quality, but let's look at what we need to find here. So which of the following statements is incorrect? When the sample size is 60, the 95 confidence estimate or interval estimate is a given. When the sample size is 100, the same confidence, let's look at what will happen. Okay, so the first thing that I would look at is, okay, what is your formula for confidence interval? So it is the x plus minus your z times that. Okay, so when we look at this, they tell us what the sample size is. They tell us what the confidence interval is, and that's it. Okay, so they give us N, and they basically give us with 95 confidence a Z. Okay, so they don't give us anything else. So that is interesting. Okay, so so I would have automatically said, because we don't have that, we don't, I just want to see if there wasn't, like this was based on other questions. So maybe just, so looking at this information, there is not enough information. So I would have said none of the above, because I need to have that at least to say something, or guessed. Let's look at, yeah, there's nothing in here that I can make assumptions. When a sample size is that, confidence interval, yeah, I don't have enough information. So maybe we just need to look if, and I'll look at where this, if this was from a previous paper, because I definitely need the mean, so that I can know what is the midpoint. Okay, so that's why I think whoever posted that on the chat, if you're on the group now, you can unmute. Otherwise, we'll just need to check if there was any other information. Otherwise, the answer is none of the above. We can look at one of the other questions that we don't need all the information, but then it is more theory around something moving in the right direction. But for this, where you have the specific numbers, we need to have a bit more of information. Okay, so unfortunately, with this one, I would have selected none of the above. Okay, any questions on your side? Otherwise, I want to look at nearly the question 4 and 5 that have more information that we can get to the answer. Okay, so let's look at this, because this is something that I think they can include in the assignments and also in the exam, because this is testing your theory, but without giving you a definition to complete or anything like that. So remember, this was the formula for the confidence interval. So here they say, assume the level of significance stays the same. So we assume that stays the same. So we can take it out of the equation when we work with this. What happens to the confidence interval estimate when the sample size increases? Okay, so if we have, so we say Z stays the same. So on this side, we have and then on the top side, we have a plus. So what happens to a confidence interval when sample size increase. So when n increases, so if that becomes more, what happens to this standard error? So if sample size increases, what happens to standard error? Anybody that wants to take a guess? Yes, is it Ronald?
It decreases.
Awesome. Okay, so your standard error decreases. Why? Because this will increase. So when that stays the same and you divide it by something that increases, that basically then shows that whole thing will decrease. So if that decreases, so if it was, let's say it was, x was 90 and that was 5, so then it would have been 95 and that one would have been, say, 85. Now it decreases, so now instead of 5, it's maybe 3. Now we have 93 as the top and we have 87 as the bottom. So what has happened? Your confidence interval, has it become wider? No, because then it would have said 98 and the lower would have been 82. So it's definitely not wider. It definitely did change. What happened? The confidence estimate becomes narrower. Okay, so you can see from a 95, now it is 93. So that gap could have been originally between 85 and 95 was 10. Now this gap is only 6. So that means that the confidence interval estimate became narrower. And this is something that they like to ask. And they can ask it with a few things. Well, 2 things. So they will all say that, okay, let's look at it. There's 3 things. So they can say to you the confidence level or level of significance changes. So that can be the 1. They can tell you that the standard deviation changes, or they can tell you the n change. And then you basically need to say what happens. So if z becomes bigger, so if we set your level of significance changes and we say z moves from, say, 90% to a 99%, that means that that whole thing will become bigger. So if that becomes bigger and that is unchanged, we'll get that it becomes wider. Okay, the same if your standard deviation increases, then that whole thing will increase, making that the whole estimate will become wider. If your Z becomes smaller or your standard deviation becomes smaller, that means that that whole answer will become smaller, and then the estimate becomes narrower. So again, nearly when you have this in the exam, it's easier to actually just add in numbers, and it can be any numbers. You could have said, okay, they tell me that level of significance stays the same, so let's assume x is 100. They tell us that z is the same, so let's assume it is 91.96. You could have added a standard deviation for yourself, and then you can say, okay, well, let's assume sample was 10, and now the sample is 100, and see what the effect is on your answer. Okay, so that is nearly a way, and they can say to you, and I'll, in our prep for the exam, I'll show you one that was in a previous year's assignment where they talked about, where they changed the Z by saying level of significance is 90, 95, and 99%. I'll check if there's one for standard deviation as well, but that we basically have a few of these as we prepare for the exam as well. So again, this is a theory question, but it's making it very practical for you to understand. Okay, questions on this one? Otherwise, we can just go to the next one. I think it's again, this one nearly gives us all the information, and then we need to look at what is the answer. So let's look at what do they give us. They give us n is equal to 30. They tell us sample mean and sample deviation. So sample mean is 90. Standard deviation is 18. Okay, we need to get the confidence interval. 99, I don't know. I go to the table. 99 is 2,58 because when it is confidence interval, we work with a two tail. So we basically have that. Let me just do the right now. So we have x, which is 90, plus minus z times, what is its standard deviation of 18 divided by square root of 30. Okay, so first I look at the answers, some of them very close. So 90 is in the middle. The lower one must be below 90. Oh, nothing can be eliminated. The top one needs to be above 90. Nothing can be eliminated. So we need to calculate this. So it is 18 divided by the square root of 30 times 2.58. So I get that my answer must be 90 plus minus 8,4787. So my top one will be 98,4787. That's the easiest one to first calculate. So let's see. Okay, not that one, not that one. 88,47. Oh. Okay, and then the bottom one will be 81.5213 when we say 90 minus that. Okay, so this one, ooh, did I work this out correctly? What do you guys think? So it's not correct. I didn't. Huh. and there's the answer. So, oh, okay, so answer, but it's not right because sample standard deviation. Sample means that we need to work with a t. Okay, so this is actually wrong. And I thought everything was correct, and there was an option for me to pick as well. Sample standard deviation, so it means the sample standard, the population standard deviation is unknown, so we need to work with a t. Okay, so mistake here. And in my exam, I wouldn't have even looked twice at it. That would have been, okay, so we need to work with a t. So t is degrees of freedom that we need to work with. So degrees of freedom is for 1, and then it's alpha over 2. So we need to work with that table. So let's just do it. Why is it not? Okay, so again, how easy it is to make that mistake. And with that mistake, that there is an answer. Which for me is now very scary. So how easy you can make that mistake in the exam as well. Okay, so degrees of freedom, n minus 1. So we're working with 29 then. Alpha over 2, so alpha is 1%. So 1% is 0.01. If we divide that by 2, we get 0.005. Okay, so we need to look at, to source the t value where t is equal to degrees of freedom 29, 0.005. Okay, let's just, I have opened let me just open the PDF again with the tables. So we can just get that. So let's, I think it is again just of the study unit 6. So let's just, and again, that's why it would be nice if you can print those tables for you in preparation for the exam as well, that you don't need to do like I would have now done to search for it. Okay, so it is 0.005, 29, so 2.756, 2.756. So very close to the 2.58. So let's just do that. That is 2.756. Is that what everybody else also got? So let me just then, so when we follow the same process of the x plus minus, now it is t. Let's just do it from the start. So 90 plus minus with t, so 2.756 times still the standard deviation, which is which is 18 divided by the square root of 30. Okay, so let's quickly see what that answer is, and hopefully now we have an option. Nine comma 0571, so plus minus, so in the end it will be 99.0571. There is the answer. Okay, so very easy to make the mistake of working with a wrong formula, and then you basically get to an answer that is an option. You think you've done it correctly and not. Okay, questions on this one? So if you want to ask a very important the sample there that one can easily misread. Okay. Let's go to the next one, and you can interrupt me if there is a question. We are a small group. Okay. So let's look at the next question. And again, there should have been commas in between again from the, so in a random sample of n equal to 1,000 observations, we found the proportion. Okay, when we see proportion, we work with a Z of successes to be 48%. The upper confidence limit for the 95% confidence interval for the proportion is. Okay, so if we're working with 0.48 as your value, then the upper confidence level will be bigger than that. Okay, so it needs to be bigger than 0.58, 0.48. So if we look at your options, that can be an answer. 0.449, okay, can't be that because it needs to be bigger than that. Can't be that because it needs to be bigger than that. Can't be that because it needs to be bigger than that. Ugh. Can't be that because we have a confidence, so it needs to be bigger than that. Okay, so without even working out anything, that would have been your answer, option 1. How we would work it out, remember, is that we have a proportion. So the proportion formula is plus minus Z, and then I think I need to get that formula because I can't remember that formula. It is, let's quickly see. And again, you guys also don't need to remember that formula. Just want to see if I've written it down in my notes. So it is the P and if I give you the other one, it is, yes, the same. And what you will see is when we're working with confidence intervals, this part is similar because if, so let's say 0.8, so 0.48 times, then we will get the opposite. So just remember the 1 minus that. So in the instance that Here they don't give us enough information, or we would have thought they don't give us enough information. But because they give us this, you have that, they give you that because that is what we already have. They give us N, so we actually have everything, and they give us 95%. 95% again is 1,96. So even though they only say we need to give upper confidence limit, we know confidence interval is always a two-tail. Okay, so because we know it is two-tail, we're just looking for the answer of that. We'll just work out the one option. So we will just work out the plus instead of adding the minus as well. But this one we could have basically, without even calculating anything, there was just one option. If we needed to work out the lower confidence, then it's different, because then there would have been three options and we needed to calculate this. Okay, so nearly again, a tip for you to say, well, if that is my proportion, because I have the 1,96, it needs to be bigger. Even if this is equal to 1, it needs to be bigger. This can't be negative. You can't square root a negative, and it can't be 0 because your n, or the proportion, can't be 0, because then that would have been 0 as well. So again, negative, we would have worked it out a bit differently. Okay, so that is nearly a summary of your study unit 1, where we look at, study unit 8, where we look at the confidence interval. We need to work out or the Z when your standard deviation is known, or you use the Z when your proportion is given. Okay, so let's go into the hypothesis testing part. So again, how I normally look at this is, let's run through the question and then we mark off the things that we do know, and normally we need to get to the incorrect one. So in testing the hypothesis, we've got the null hypothesis, we've got the alternative. Okay, bigger than means one tail. Okay, so it is one tail. At the 5% significance level, so alpha is the 5%. So let's look at 5%. One tail. So 95%. Let's look at 95% one tail. 95% one tail. Okay, so that is probably the incorrect answer. Let's just look at other questions that were all options. If a sample or proportion is that, sample size is that, which one following is incorrect? Okay, so let's work out standard error. Standard error is basically your standard deviation divided by the square root of n. Standard deviation. Okay, so now we need to just remember it's the proportion one. So this is going back to study unit, I think 7 or 8, where we did the standard error. Okay, so then it is, okay, so what would you have done here? What value would you have used? And I think that is what makes this one so difficult. What value would you have used? So anyone? So do we use that value of 0.4, or do we use that value of 0.45? Okay, so what would you guys have said? Which one do we use?
I'll use the sample proportion 0.45.
Okay. Okay, so that is what we're testing against. So I would also, because, and that just shows again how we need to make sure. So when we do Z, we'll do that. Yeah, so this is quite interesting. This is why this specific question is so difficult. In the sense of, I thought first it was easy because you work with a Z, but now you need to work out your standard error. You need to look for your critical value. You need to work out the t-stat, and then you need to still make a decision with a p-value as well. Okay, so then if you look at this part, so that then is fine. So we now need to basically, there's one that we need to work out. See, so if you say you use the sample proportion, what will you do then if you work it out with a Z as well? Would you also use, because then you basically swap it to a round. Because then, so here I would have said 0.45 minus 0.4, and then that divided by what we're going to work out here. So let's just be interesting to see what the difference in the answers are as well. So let's say 0.4 times 0.6 divided by sample size of 49, square root of that. Okay, 0.7143. Okay, which is that one. Okay, so and this is what is so difficult with this, because it's, I think what we need to take our direction nearly is what they are giving us here, so that we know that that one what we're testing it against is the P. So when we look at the standard error as well, we will use this standard error formula. Okay, which then is, why is my calculator not working this out correctly? Okay, so when you guys worked it out, what do you get for your standard error? Okay, because I get something different. I don't get that. So even if we worked it out, I get 0.07. And it doesn't matter if I use that over proportion part, I get 0.07. Okay, not 0.007. Okay, so that one is wrong. So we need to check that one again. The P value, we're going to test against that. So when you look at your Z table, we calculated the Z. So that Z value of 1.7143, to get to the P value, we look at what that is. Okay, so again, if we have, okay, so it's easier for me to look at the negative. I need to get the, okay, so let's 0.71. I now hope that is rounded off correctly. 0.7171, 0.2389. I say at least 0.2389, which is that. So let's see, why is that wrong, or did I make a mistake in this editing, which can also be. So let's just, by say 5% level significance or 5% significance level, they tell us it's one tail. So I would go to this and say 5% significance. So that would be, what would you have said? Was 1.645 over 1.96? If they tell us that is, they tell us alpha is 5%. So this feels to me that there was a mistake in this question as well. Was it from a previous exam paper? Let me check, because this feels that there's too many mistakes on this one. There was another mistake at that one as well, which was also a previous paper. a lot of mistakes. So what happens in the exam if a mistake like this comes in is that, okay, let's quickly see here. I've got the answers. Yeah, I see. So let me just check. So that one they say is true. So at the 5% level, why am I reading this? I'm reading it wrong. So at the 5% one tail, it is 1,645. I'm reading it wrong. I thought it was, I must get bucket tonight. So we said 5%. And we said it's one tail. So 5% one tail is freaking 1,645. 1,645 is correct. So that one is the incorrect one. Okay, because it should be 0,07. Okay, so happy with that. I now confused myself and I confused every one of you. One tail, 95% because it is 5%. Do the cross, it is sitting at the 1,645. Okay. Let's just take the rest out there because that. Okay. Okay. So let's look at the next question. Okay, the next one, a random sample of 200. Okay, so N is 200. 88 are defective. So again, 88 will be your P. So that's for 88 divided by 200. Let's just look what else do they give us. We need to test against that, against the null hypothesis and alternative. Okay, not equal to 2 tail. 5%. So let's get this right this time. 2 tail, 5%. Let's just, I want to just get out of this and then. Okay. 2 tail, 5% gives me that. 1,96. So when we work with the Z is going to be equal to 1,96. That is your critical value. Okay, so we need to work out the p-value. So we need to go to work out that t-stat, so the Z value. So just check for me, that will be 0,44. So that would have been equal to 0,44. So we do the p minus the sigma, 0,4 divided by just check. So it will be divided by that again. So it is 0.4 times 0.6 divided by n, which is equal to 200. And we need to take the square root of that. Okay, if I look at my options, that is probably going to be the equal my z value. So let's just see 0.44 minus 0.4. So at the top, it gives me 0.04. And I divide it by 0.4 times 0.6 divided by 200. If I take the square root of that, it is 0.0346. So if I say 0.04 divided by 0.0346, I get the answer of 1.15. Okay, so that was my z that I need to work with. So I need to say what is my p-value. So I need to look at where it is 1, will it now be 1.5 or 1.6? So that would be 1.6. So let's just get z equal to 1.6, 1.16. Let me just 1.16, 1.16, 1.1. 0.123, 0.123, 0.123, 0.123. Okay, so that area is 0.123. What will be my p-value?
Sorry for disturbing.
Yeah.
Yeah. That 1.16. Why is it that you are looking at it from the negative side? I'm sorry, I didn't attend the last session, so I might have missed something.
No. So I just,
the negative
for
side
me,
of the table.
So I want to get that smaller part. So I could have gone to a positive, and then I could have gone that whole area. And then I need to say 1 minus this area to also give me. So I could have done that. Let's go to the positive 1.6. 1.16. 1.16. So it would have given me 0.8770. So this whole area then would have been that 0.8770. So then I would have needed to say still 1 minus 0.877 to get that smaller area. So I just take a shortcut and automatically go to the negative table to get me that. But you could have gone to look at the positive, but remember you're looking for that small area. So then you just needed to say with a positive table 1 minus that to give you that smaller area. Happy with that, Ronald? Or
Yes, thanks.
cool. Okay, so now the next nearly thing that we need to do is remember this is two-tail. So if we calculated that as 0.123, what is my p-value? So will it be that answer? Okay, so the important thing is that it is that part, but because it's two-tail, I need to put that part with it. So that part would also be 0.123. So when I look at the p-value, it is both that one and that one, which will give me 0.246. So remember, we're working with two-tail. Because it's two-tail, we basically need to multiply that by 2. If it was only that or smaller, then it would have been one tail, and then that would have been our answer. Okay, so what we do with this is that here they've given you the Z. So sometimes when you worked out the Z, and one just makes an easy mistake to say, well, oh, I've worked it out 1.1. Oh, there it is. But then you need to we need to work out the p-value. Then what they also do is that they give you, and Ronald, that is nearly very similar to the 0.877 as an option. So again, if you went and said, let's look at the positive table, you could have then stopped at that point and would have said, oh, that looks close enough. Let's go for option 5. But then the next set is actually, okay, but it's a two-tail, and then we need to multiply that small portion by 2. Okay, so that's nearly again showing the difficulty in this study unit, because again, this is a lot of information that you guys need to take in. Okay,
I think you should recommend that these people should stop doing this of putting answers that are not answers. This thing is hard enough already, and now everything you find is an answer. Everything you find is an answer. It becomes difficult, more difficult.
No, and that is why you would, when you guys see this, some of the previous papers also had the option of not one of the above, and that has been taken out of all your answers in the exams as well. There will not be an exam question with an option at the bottom that says not one of the above, because it is later you get so confused and then it's nearly like, but it must not be one of the above. But I think you are right in certain things that it should not be too close in any case. So, but here they basically test that you understand the difference between one and two tail. Yeah. So it is unfortunate, and the worst thing is when I made the mistake in which one was it? This one. When I made this mistake, there was an option for me, and I followed step by step the formula and everything, but just because I used the wrong one, there was an option. So yeah, I feel your pain. It is not easy. Okay, the last one, and this one where also you would see in our previous session, we also looked at one of these. If it's not in the assignments, this is one that they really like to ask as well. So they give you information, and with that information, they want you to write down what is the null and alternative hypothesis. The one thing when we look at this, and so you would have seen in all of these. So let's look at where was it? So okay, so this was proportion. So So I actually used all of them as proportions. So when you do work with a proportion, the null hypothesis will always look at this proportion sign. You will not see this one as your null hypothesis. So when we look at the mean, this will be the sign that we use for the mean. We will not use this one. Okay, so this is the one that's the standard that we use when we work with hypothesis. So if you look at this set of options, not an option, not an option, because it needs to be the me. Okay, so then let's go and look at what else they give us. A random sample of 10 public swimming schools in a province is selected. The sample mean for the random sample is first with a standard. The claim made by the swimming pool administrator is that the pH value of a swimming pool is greater than. Okay, so null hypothesis is equal to 7.5. The alternative, they say it must be greater than. Okay, so there they tell us greater than, there's greater than. Okay, so the only one left was that one. Okay, so again, nearly eliminate two of our options, so there's 3 left. Let's see what is else available, and then we select it. Okay, so that was it. For the last 3, I actually have given some assign or the answers to the questions as well, that you can also work it out. So I'll load this on YouTube, the session, then I'll share the presentation in our chat as well on WhatsApp, and I'll share it in the Teams folder as well. Is that a bit better for study unit 8 or 9? It's still difficult. I think personally, I think study unit 9 is one of the most difficult ones in this subject. So yeah, are you a bit more comfortable with these 2 study units? And nearly, I think this one, nearly go through the two recordings for your assignment preparation as well. Okay, and then from next week we'll tackle the next set of study units. Okay, good luck with assignment 4 that needs to be handed in, and then we'll chat again next week with the next study unit that we'll prepare. Okay, have a good evening, everyone.
Thank you, sir.